Hello.
Hello.
Okay, you can hear me.
Yes, I can.
Good. So we are going to go over chapter 6 today. Do you have any questions on chapter 5 or 4?
Nope, not at the moment.
Okay. As usual, if you have a question, you can always send me an email. So in chapter 5, we learn about discrete binomial distribution, discrete distribution in general, and a special case is a binomial distribution. In this chapter 6, we are going to learn about a special type of distribution, which is called the normal distribution. The normal distribution is actually an example of continuous probability distribution, while the binomial is an example of a discrete distribution. So we will first start with the definition of what we consider a normal distribution. It is a distribution that has a bell shape. Its curve is symmetric about the mean. The mean, the median, and the mode are the same. The curve approaches the x-axis but never touches it, and the total area under the curve is 1. I'm going to give a description on the whiteboard about it. So we have something like this. So it's bell-shaped. At the middle here is the mean, which we write as mu. Because it's at the middle, it is also the median. The median is the position of the middle of the distribution. And we can see it's at the level of the highest probability, so it is also the mode. It is a symmetric in the sense that the left and right side are essentially the same, and the total area under the curve is 1. One of the important property of a normal distribution is the empirical rule. The empirical rule states that within one standard deviation, we have 68% of values. And within 2 standard deviation, we have 95% of values. And within 3 standard deviation, we have 99.7% of values. So this is further distributed according to the symmetric property, which we are going to look at in the next. So this is a distribution, a normal distribution. We can see that within one standard deviation, that is from mu minus sigma to mu plus sigma, we have 68% of values, which is actually shared between the 2 sides of the mean, 34% to the left, 34% to the right. And between the first and the second standard deviation, you have 13.5%. Here you have 13.5%. Between the second and the third, you have 2.35. So if you add the values that are to the left, you are close to 50%, which is about 47.85. So we are not accounting for 0.15% on both sides. So we can say that below the second standard deviation, we have 2.5% of values. This can be used sometimes to compute probability about a normal distribution. This example, we say that the playing life of a sunshine radio is normally distributed with a mean of 600 hours and a standard deviation of 100. What is the probability that a radio selected at random will last from 600 to 700? That actually means that the lifespan is within the first standard deviation. the standard deviation is 100, the mean is 600. And we know that within the first standard deviation to the right of the mean, we have 34% of values. So the probability that the lifespan is between 600 and 700 is 0.34. So when you have a question in which the values in the probability expression are integral addition to the mean by standard deviation, you can just position those values according to the number of standard deviation you are moving away from the mean to determine using the empirical rule the probability. More generally, statisticians use what we call the standard unit, which is generally used because there is a table of probability which is called the standard normal distribution table. So if you have a normal distribution X with mean mu and standard deviation sigma, you can standardize it by using the formula Z equal to X minus mu over sigma. This gives rise to a normal distribution which is standard. It actually has a mean of 0 and a standard deviation of 1. So whenever you see a standard normal distribution, you should know that the mean is 0 and the standard deviation is 1. Let's use this example. A pizza parlor franchise specifies that the average amount of cheese on a large pizza should be 8 ounces and the standard deviation only 0.5 ounce. An inspector picked out a large pizza at random in one of the pizza parlors and finds that it is made with 6.9 ounces of cheese. Assume that the amount of cheese on the pizza follows a normal distribution. If the amount of cheese is below the mean by more than 3 standard deviations, the parlor will be in danger of losing its franchise. Remember that we said that within 3 standard deviations, we have 99.7% of values. So a quantity which is out of that should be considered as an outlier. So we may want to know how far away is the quantity that we have from this sample from the actual mean. How many standard deviation from the mean is 6.9? So we subtract 6.9 from the mean. We subtract the mean from 6.9 and divide by 0.5 and we get negative 2.2. Negative 2.2 is still within 3 standard deviation. We can also do the reverse calculation. Given the z-score, we may want to find the raw score x using the reverse formula. So if you have the z-score with mean and sigma, the raw score x is z sigma plus mu. Sometimes we have this type of situation when we are dealing with finding the inverse distribution. So we can use the empirical rule also to answer questions about the standard normal distribution, but we need to understand that with standard normal distribution, one standard deviation is 1 because the standard deviation is 1. 2 standard deviation is 2. So we may want to find the area under the standard normal distribution to the left of z equals to negative 1. So this is negative 1, and we know that this side of the mean 0 to negative 1 is 34%. So the left side is 16%. More generally, we can use the standard normal distribution to answer questions about the left side of the Z distribution. The Z distribution table or the standard distribution table is a table like this. On the first column here, you have the Z value with the first decimal. And on top here, you have the possible completion of the second decimal. So when you are asked to find the area to the left, you just read the Z value and complete it with the second decimal. For example, for -1, we have -1 here, -1.0, and then there is no decimal, so we are here. And that area is actually 0.1587, which, as we said, is approximately 0.16. But it is easier to use a calculator to find area to the left. So it is here on the PowerPoint so that you learn how to read the table, but you can also use your calculator to find that area. Find this area to the left of Z equal to 1.18. So this is 1.18. You will go to the Z distribution, to the standard normal distribution table, and identify 1.18. So this is 1.1, the first decimal. And the second decimal is 8, which is here. So the area to the left of 1.18 is 0.8810. So do you have your TI-83 or 84 calculator?
Yeah, I have mine.
Okay, so let's practice using that. When you set it on, let me know.
I have it on.
Okay, so you go to second function. You will see second function and then distribution.
Okay.
Then you will go to the second one.
Is it normal CDF?
Normal CDF, yes.
Okay.
That normal CDF gives you the area to the left of Z.
Okay.
So what do you have? What do you have to complete there? Because each calculator is different.
It says like lower, upper,
Okay.
the U and then sigma.
Your lower will be some negative exponential.
Yeah. -1E99.
Okay, that just means that is a very large negative number to start negative infinity. Then the upper value here will be 1.18. Okay. Then the mean by default is 0, and the standard deviation by default is 1.
Is 1.
For the standard normal distribution. So what you are doing is probability that Z is less than or equal to 1.18. So you will find the answer.
0.88.
Yes.
Okay.
So if you were having greater than 1.18, the lower value, if you were to find probability that Z is less than, I'm sorry, Z is greater than or equal to 1.18, then your lower value will be 1.18. And the upper value could be a large number. You can just write 1 million. And then you will get something which is equal to 1 minus probability that Z is less than 1.18. If you are looking at the normal distribution table, you will have 1.18 here, and this is the area to the left. The total area under the curve is 1. So to find the area to the right, you do 1 minus area to the left. But with your calculator, you can just enter lower value 1.18 and upper value like 1 million or 1,000. Let's go back to the PowerPoint. We are going to be using the calculator more and more. So for those without calculator, but I expect all of you to have a calculator, without which it will be very difficult for you to do so much of the work. So if you are using the table, you might want to find the area between 1 and 2.7. Between 1 and 2.7. So to find this type of area, 1 and 2.7, is the probability that 1 is less than Z, less than 2.7. Generally, you write this as probability that Z is less than 2.7 minus probability that Z is less than 1. So you can read both of these from your table. But if you are using your calculator, you will just go to second function distribution, and your lower value is 1 and upper value is 2.7. Can you do that with your calculator?
Did you say the lower one is 1 and then?
As you can see, Z is greater than 1 and less than 2.7.
Okay.
So lower value is 1 and the upper value is
2.7.
Yes.
Okay. 0.155.
Okay. So if you were reading the table, you will find the area to the left of 2.7 to be 0.9965, and the area to the left of 1 is 0.08413. 0.8413. Then you get this answer. If you have a question like find the area, these are the possible questions you will be having on your homework and quizzes. Find the area to the right of Z equal to 0.94. If you are using your calculator, this is just like probability that Z is greater than 0.94. So the lower value is 0.94. The upper value is a very large number, which is, you can take 1,000, even 1 million. But if you are reading the table, you will read the table for 0.94. It will give you the left area, and you subtract it from 1 to get the right area. But when you are using the calculator, you can get it directly. Do you have an answer?
I put in the 0.94 and I did like 1,000 for the upper, and I got 0.1736.
Yeah. So the minus e is the power of, it's just a large number. Sometimes you will want to use, and if you have the area to the left, you can just use minus 1000 as well.
Okay.
At the lower value, and the upper value is the number you have. That works for standard normal distribution. Now, what we were doing was for standard normal distribution, the z value, which has mean 0 and standard deviation 1. Now we are moving to more general normal distribution. Here we will have a value, a random variable x, which is normal, and then between a and b. So if you are to read the table, you will find the standard score for a and b and use the table to find the probability. But because I am encouraging you to use your calculator, you are going to adjust the mean from 0 to the new mean and the standard deviation from 1 to the new mean to answer questions about a regular normal distribution. So we are going to look at some example. So here we have a mean of 10 and a standard deviation of 2, and we want to find the probability that x is between 11 and 14. So here you will use your calculator, consider lower value is 11, upper value is 14, mean is 10, and standard deviation is 2. But for those who don't have their calculator, you will have to make a conversion to this. Convert this 11 and 14 in standard form. That is 11 minus 10 over 2, and then 14 minus 10 over 2. And then read the standard normal distribution table in your textbook. So this is what we get. And we now have two standard value, 0.5 and 2. And the question is, what is the probability that the standard value is between 0.5 and 2? So you read the table for 2, the standard table for 2, and the standard table for 0.5, and do the subtraction. Are you able to use your calculator to do it?
I kind of got confused, like when you were explaining it with the calculator.
So it's just the same thing. Just go back to distribution, second function distribution.
Okay. And then the normal CDF.
Yes.
Okay.
Normal CDF. Lower value is what?
Would it be 10?
No, you are looking for the probability that x is greater than 11 and less than 14. Right?
Yes.
So what is the lower level of the interval? You see, we are finding the probability that x is greater than 11 and less than 14. So the lower value is 11, the upper value is 14.
Okay. That makes sense.
So the mean is 10 and the standard deviation is 2.
Would I be getting a negative number?
You cannot get a negative number for probability.
Okay, I didn't add something in then. Okay. Oh, that's what I forgot to do. I forgot to put in the mean and the standard deviation.
but still you were not supposed to get a negative number. Anyway, try again.
Okay. I still got a negative number and I don't know why.
Okay, so go to second function,
Okay.
distribution.
Yep.
You take the second one, normal CDF. Is that what you are taking?
Yeah.
Okay. So what do you have as lower value?
11. Oh, okay. I put 10 instead of 14. Okay. Now I should be. Now I got a positive number. Yeah. 0.286.
That's what you can you see the screen?
Yes.
That's what you should get. So another type of question that you will have is the inverse normal distribution. That is, sometimes you are given the area and you are asked to find the z value or the x value. Z value is when it is a standard distribution. X value is a general distribution. Let's look at this example. Magic Video Games sells an expensive video games package. Because the package is so expensive, the company wants to advertise an impressive guarantee for the life expectancy of its computer control system. The guarantee policy will refund the full purchase price if the computer fails during the guarantee period. The research department has done tests that shows that the mean life for the computer is 30 months with a standard deviation of 4 months. So you record the mean and the standard deviation. The computer life is normally distributed. How long can the guarantee period be? If management does not want to refund the purchase price on more than 7% of the video package. So here we have a mean of 30 and a standard deviation of 4. We want to know what proportion of those packages will be refunded so that we don't exceed 7%. So the proportion that we want to accept for refund is 7%. We want to know the lifetime that will permit that. Let me show you that on A. So we are going to make a normal distribution. And this line is the lifetime. It has a mean of 30. So we want to find a guarantee period. We will place the guarantee period here. That is the time within which, if the package does not work, you can refund it. We call it A. So this area left of A is what is given to you as 7% or 0.07. So we want to refund only 7% and you are asked what is the value of A. If you are not using calculator and you are reading the table, you will want to find first Z. You will want to find the value of Z so that the area to the left is 0.07. That is how we will proceed on the PowerPoint. Once we have that Z, we will solve the equation x equal to sigma Z plus mu to find the value. But as I'm saying, calculator is required in this class because without it, you will have a lot of trouble following the use of the table all the time. So with your calculator, this is what you will do. You go to second function, distribution. Can you do that with your calculator?
Yes.
Then the third option is inverse normal.
Okay. I got that. And then it says like area and then the mean and then standard deviation.
So the area that is mentioned there is the area to the left. So you have to be careful when you are reading your problem to identify where the area is. Wherever that area is, you want to be able to determine the area to the left from that other area. So for this one, because we want to refund from the early period of the package, the area is to the left. So the first 7%, that's area to the left. So you will put there 0.07. And now mean is, do you know what the mean is?
Would it be 30?
30 months. And the standard deviation?
4
4 months.
What was that?
4.
4.
Yes.
24.09.
So hold on to that as we are going through the method again. So this is the, you can see on the PowerPoint, this is the description of what it is. The mean is 30 and you want to find X so that the area to the left of X is 7%. So if you are using your calculator, you get 24. But if you want to do it manually, reading the table, you will want to find the area to the left of Z. You can still use your calculator to do that, but you don't need to. You will find, to find the Z value, so the area to the left of Z, you will put mean equal to 0 and standard deviation equals to 1. And the area is 0.07. You will look into the table for the closest number to 0.07. It will be a number between these two values from the table. So this area that I am showing is the area where we express probability. Because we want to find the Z value from the table, we will go to the left and identify the first decimal, the value with the first decimal, and complete it with the second decimal. So we will have something like negative 1.475, for example. And we are going to replace that into this equation to get the number of months. So I do encourage everybody to have a calculator because doing these things manually is time consuming, and you have this calculator that is supposed to serve for that. So in 6.4, sampling distribution. So we have learned about the normal distribution, which is a random variable, as we say, with the curve that is bell-shaped. We use the area under the curve to find the probability. Most of the homework that you will have will be for the standard normal distribution and for the regular distribution. They will ask you, find the area to the left, find the area to the right, find the area between two values. When it's area to the left, you want to express it as probability that Z is less than. That means you have the upper value and you don't have the lower value, which is a negative large number. If you want the area to the right, is probability that Z is greater than a certain number. That number becomes the lower value on your calculator and the upper value is, let's say, 1 million. But when you have area between two numbers, it's easier. You just, the lower and the upper value is easily expressed by the two values. Some other type of question that you will have at homework will be, find the Z value so that the area to the left of Z is, you use the inverse normal. Find the area so that find Z so that the area to the right. But if you are told the area to the right, maybe if the area to the right is 0.6, you should know that the area to the left is 0.4. On your calculator, you will use 0.4 because the calculator is only using area to the left. The calculator always use area to the left. So as you do your homework, if you have a question, send me an email. I will always be ready to help you. So in sampling distribution, we are getting back to statistics. So remember that in statistics, we say that a random sample is a portion of the population that is representative of the population. So we will consider sampling techniques as a method, as a probability experiment in which we want to choose a small portion of a large population. Just like when you have a bag with 20 balls and you want to select 7 of them at random. This is the way we will consider a population in which you want to take a sample of 30 individuals. So when we do that, we get a random experiment and the outcome are the possible random samples. So now we are going to look into the sample mean as a number associated with the random sample, which in turn defines a random variable. So we will now be thinking about the sample mean as the random variable of sample means. That is, you take a random sample and you compute the mean. It defines a random variable. We can do the same for standard deviation or even for proportion. We may want to know what is the proportion of the population that is interested in favor of a certain opinion. So we will take a sample maybe of 30 individuals and count the number of people that are in favor of that, and it will give us a sample proportion. So anything that we get from a sample now, when that sample is a random sample, it will define a random variable. And we will be interested in what is the mean of that random variable, what is the standard deviation of that random variable, and under what condition is that random variable a normal random variable. I've explained all of what we are talking about now. So when we consider the sample mean X bar, it is called the sampling distribution of sample mean is denoted by X bar. It has mean mu X bar, which is the population mean mu. So when we think about the sample mean now as a random variable, the mean of that sample mean is the population mean. And the standard deviation of that sample mean is the population standard deviation. So we are going to be using those to, just hold on 1 minute, please. Okay, so this is very important for us as we want to discuss about the sample mean. So what you want to know about the sample mean now essentially is that the sample mean has mean mu, the population mean, and standard deviation sigma over square root of n. Sometimes you will be asked to find the standard deviation of the distribution of sample mean. It is just dividing the population standard deviation by square root of n. We are going to look at some example. So when the population is normally distributed, if the population is normally distributed, the sample mean is also normally distributed. But if the population is not normally distributed, you will require the central limit theorem, which states that if the sample size is large enough, then the sample mean is approximately normal. Essentially, what you want to retain from here is that in order to use the normal distribution for the sample mean, either you should check that the population is normally distributed, or you should see that the sample size is at least 30. When one of those two conditions is met, you can use the normal distribution for the sample mean. Okay, now let's do an example. Suppose a team of biologists has been studying the Pinedale Children Fishing Pond. Let X represent the length of a single trout taken at random from the pond. This group of biologists has determined that X has a normal distribution of 10.2 inches with mean 10.2 inches and standard deviation 1.4. These informations are for the population. What is the probability that a single trout taken at random from the pond is between 8 and 12 inches? So this is a question about a single trout. So it is about the random variable itself, X. So it's about X. What is the probability that X is between 8 and 12? You can either convert this in standard form and read the table or use your calculator. So I will advise you to use your calculator at this point with a mean of 10.2 and a standard deviation of 1.4. Can you use your calculator here?
Yes, I can.
Okay.
And this is still normal CDF.
Yes.
And then for the upper and lower,
is the probability that X is between 8 and 12. So what do you think the lower?
8.
And the upper?
12.
Now what is the mean?
10.2.
And the standard deviation?
1.4.
Okay.
0.843.
0.843. That's what you see here. So now, I want you to remember that this was a single trout was selected at random. What is the probability that the size is between 8 and 12? The next question is different. What is the probability that the mean length of 5 trout taken at random is between 8 and 12? Do you see the difference between the two questions?
Yes, the last one was asking for only 1, and then the second is asking for 5.
The average of 5. So for the average of 5, you are going to use the sample mean as your random variable. And in order to use that, you will want to know what is the mean of the sample mean. The mean of the sample mean is the same as the population mean. And what is the standard deviation of the sample mean is the standard deviation of the population divided by square root of n. Do you see it on the screen here as I'm showing?
Yes.
So the standard deviation was 1.4. You divide it by square root of n. N is the number of trout, which is 5, and you get 0.6. You can just practice with your calculator to do that. 1.4 divided by square root of 5. Are you able to do that?
Yes.
So what do you get?
For the probability, 0.997.
How did you do that? You are doing the probability already. I was saying you should find this standard.
Oh, you wanted me to find that first.
Yes, I want you to practice doing 1.4 divided by square root of 5, so that I am sure that you can do that each time.
Okay. Sorry about that.
No problem.
0.63.
0.63. So now you record that 0.63 if you are doing a problem either on the quiz or homework, And now you are going to do this, find the probability that the sample mean is between 8 and 12. So the lower value is 8, the upper value is 12. The mean is 10.2, and the standard deviation is now 0.63, not 1.4. So for those who are not using calculator, they will need to convert it in standard form and then read the table. Okay, I see you got the right answer.
0.997.
Right. It's much easier when you are using calculator. So you want to remember that when a question is about the single value, you just use it as we learned in 6.3. If it is about the sample mean, you will adjust the standard deviation according to the sample size by dividing the standard deviation by the square root of the sample size. So essentially, that's what it is. We could go through another example, but I think it's not necessary. You can just go through it on your own. It's essentially the same work we are doing. When you take a single value, you use the mean and the standard deviation. If you take a sample size, you divide the standard deviation by the square root of the sample size and do the same work. Okay, that is it with chapter 6. I will encourage you to practice with your homework. And if you have questions, send me an email. And if need me, we can also, if I cannot explain to you by email, I can arrange to meet on Zoom if you like. Okay.
Thank you.
You're welcome.